In this video, we'll be looking at a polynomial function and determining the possible number of positive, negative, and complex zeros using Descartes' rule of signs. Descartes' rule of signs says that the number of positive real zeros is equal to the number of sign changes in f of x, or is less by an even integer. The number of negative real zeros is equal to the number of sign changes in f of negative x, or is less by an even integer. The function that we'll be looking at is f of x is equal to negative 2x to the fourth plus 3x cubed minus 5x squared plus 4x minus 1. So let's just look at f of x first and find the possible number of positive real zeros. We can see that this first term is negative because of the negative sign here. So this first term is negative. The second term is positive. The third term is negative. The fourth term is positive. And the constant term is negative. So we can see a sign change going from negative to positive. We have another one going from positive to negative. We have one going from negative to positive, and then we have one going from positive to negative. So we have 1, 2, 3, 4 sign changes in f of x. That means that the number of possible positive real zeros is 4, or 2, because you reduce by an even number, or 0. Now, to determine the number of possible negative real zeros, we have to examine f of negative x. F of negative x, we can find, negative x, by substituting negative x into our function every time we see an x. So we have negative 2 times negative x to the fourth power plus 3 times negative x to the third power minus 5 times negative x squared plus 4 times negative x minus 1. Now, when we raise a negative number to an even power, there's no effect on the sign of the term. So this will be just a negative 2x to the fourth. When we raise a negative x to the third power, though, when it's an odd power, that changes the sign of the term. So instead of a positive 3x cubed now, I'm going to have a negative 3x cubed. On this one, I'm raising my negative x to an even power, so there's no change in the sign of my term. That'll be a negative 5x squared. This one, positive 4 times a negative x will be a negative 4x, and then minus 1. So we can see then that this term is negative, 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 and negative. So there's no sign changes in f of negative x. Now we know then that a polynomial which is fourth degree will have at most 4 zeros. So we're going to have a total of 4 zeros for this function. If we have four positive zeros, then we'll have no negative zeros and no complex zeros. Because the total number of zeros has to add up to 4. Now, we're going down by an even number, so if we have 2 positive zeros, I can't have any negative zeros because Descartes' rule of sign says that since there's no sign changes in f of negative x, there's no negative zeros. So I can't have any negative zeros, which means that my other 2 zeros are going to be complex. And then finally, I could have no positive real zeros. And again, I can't have any negative zeros. Which means that all of my zeros will have to be complex zeros. So complex will be 4. Now that makes sense that these would be multiples of 2 because remember we have the conjugate zeros theorem that says if a plus bi is a 0, then its conjugate a minus bi will also be a 0. So complex zeros come in pairs. That's why we had to go by an even integer when we reduce the number. So this is our possible signs on the zeros of this function.